My mom was thinking about it too. She was thinking about what he said.
You're staying home for a whole week.
How you know we staying home for?
It's spring break.
I'm not staying home.
Oh,
I'm
yeah.
saying you're not coming to school for a whole week. Why take another extra day like that?
No matter where I'm going.
That's what I'm
I'm
like, oh, I have a whole week off. I'm gonna take an extra day.
My mom is
Okay, so in elementary school, though,
Right, I knew that somewhere.
Alright, so I'm gonna show a little video of this tower in Miami. We're on page 798. We're doing number 20. It's about Miami. I will be taking care of my family as mothers do. Typical parent adult stuff, you know.
Are you gonna go out?
Yeah, you can use it. Are we ready? Let's focus on math class. I'm just a regular person. Alright, so today we're starting operations with radicals, so square roots and cube roots. We did this just slightly in the chapter on exponents, but now the whole chapter is focused on radicals. No, this is just brand new starting today. Oh, yesterday on Khan Academy, the first one was radicals. Go ahead, sorry. Yes, answer this in your notebook. Alright, close your Chromebooks. You should not be on your Chromebooks. I see 6 people. You don't need to go on there. You don't need to be on Schoology right now. Okay. The velocity in feet per second of a dropped object is given by v is the square root of 64d. Velocity is another way of saying speed. So the speed of this thing is an actual square root function. I know you guys always want to know, like, why do we have to do this? Well, the mathematicians and the scientists, they say, well, they use this equation, so you guys might as well see it too. It's 64 times d. This is the speed of an object dropped. Have you guys ever heard, like, they used to say this, if you drop a penny off the Empire State Building and it hits somebody, it would kill them?
Does it?
Yeah. I would think so.
Oh yeah,
I think it would. Because it just gets faster and faster and faster, and then by the end it turns into like a bullet. Because of the force of gravity. So this is the equation that will tell you how fast an object is going when it's falling. Yes, 64 times d. So your book, as you know, likes to pull in problems about Florida. This is talking about an object falling off of the Panorama Tower in Miami. So letter A, where is the Panorama Tower? Miami. Letter B, how tall is the tower? 868 feet tall. I'm gonna show a short video about it so you guys get an idea of what we're talking about. Why not, right? I guess it's the high. It was 6 years ago. It was the tallest tower.
Live, the news on NBC6. Then reaching new heights, Miami's Panorama Tower tops off, and we take you inside the history-making new building. Well, tonight we're taking you inside the highest residential tower being built in South Florida. Florida's East Coast Realty topped off the Panorama Tower. NBC6's Erica Glover has the story all new tonight. 85 stories above busy Brickell streets are panoramic views unlike any other.
You could be on the 20th floor with wonderful views, or you could be on the 85th floor with spectacular views.
Panorama Tower reaches higher than 2 football fields stacked on top of each other. At 868 feet, Panorama is truly the tower that rises above all, but it's not just the tallest building here in Florida, it's breaking other records as well.
Panorama Tower, tallest building in Florida, tallest residential building south of New York.
With a price tag of more than $800 million, Panorama includes 821 luxury rental apartments, 208 hotel rooms, and 150,000 square feet of office and retail space.
It takes so long, these projects, 7 years, and every milestone is such a relief.
Developers for the luxury rental tower on Brickell Bay Drive say they're on track for October completion.
And next thing we do, we've got to open it up and invite all the residents to come in, and then we'll have the best residential property in the city.
3 restaurants, 3 private theaters, and a pool deck overlooking the city and bay, 22 floors up. Miami's tallest skyscraper might not hold that title for too long.
It's hard to top until we actually top it ourselves. Our next building coming up will actually be even taller.
In Brickell, Erica Glover.
Let's hope they can sell them. Yeah, it's like apartments and then also hotels and then like business offices. That's it. That's it. Just is anybody familiar with Miami? Who's driven through Miami? It's impressive. I actually just really drove through it a couple years ago. It's a huge city. It's some really tall buildings. There's like 5 other buildings almost just as tall as this in Miami. Alright, so what we want to know is if you're at the top of that building and you drop something, how fast will it be going by the time it hits the ground? So apparently if we just plug in the distance it falls right in here, use a calculator, it'll tell us how fast it's going. So we're going to go with 64 times 868. So grab that calculator and use your square root button. The whole day today is about square root buttons. If you want to turn in your phone at your ID, I'm going to use the squiggle because we're going to round it 236. This is feet per second. Okay, so that's how many feet per second. I went ahead and converted this. And so I'm going to answer in a complete sentence. An object falling 868 feet has a velocity of, it's 160 miles per hour. Yeah, this is like when it hits. What's the object? No. It depends about the force of air. Like if you're gonna, as long as it's a solid object, it's gonna fall at the same speed. But like a surface area will slow something down. Like a parachute goes more slowly because it catches air at the surface area. So, surface area more sensitive. Mhm.
This is more like a science question.
Yeah.
So why do towers float?
Why do you have what?
Why do towers float? You're not falling. You're
Yeah.
not rising. So you sit there. Nothing happens outside the surface area.
No, they do. They're little water droplets. They do surface area. It's because it's almost a gas. It's like steam. Almost when you think about steam, right? And then it has to do with the layers of the atmosphere. The higher up you go, the lower the gravity, like the further away. So yeah, they just collect up there together. But eventually they do fall, right? In the permanent rain. It is interesting to think about how clouds are floating.
Like, I wish I could do that. I wish I could float.
What's the answer? We've just plugged in the height of the building into the formula. 236 approximately. I rounded it. And then this is miles per hour. Landon, do you want to add anything to the conversation about what affects velocity of a falling object? The surface area. The maximum velocity it can hit.
If you're walking by a really
That's
close
how
building
far it
and
is.
water just fell on you like a whole puddle, because somebody drew it off the edge, would you be mad?
You got it.
But like,
Alright,
the shape of the object too. Because like, what if it's like shaped air by air? That's through air.
Yeah, that's kind of what I was saying, surface area. Like something aerodynamic, that surface area is staying there at the bottom.
That's right.
I will. Mass and external forces and acceleration. This is the physics answer. Mass, surface area, and density. Okay, that's good. That's good. This the calculators you're allowed to use on exams don't do that. You have to figure out how to do that yourself. But if you want to convert it to the decimal, that was converted to miles per hour. So there's I think it's 5,000. Yeah, 5,280. There's 5,280 feet in a mile. So you convert it. 5,280 feet per mile. So that's how many feet you'd have to walk to make it a mile. Alright, that's it for Bauer. Let's do some notes on properties of radicals. There's an important rule that you'll use for your assignment today that simplified radicals have no crazy roots. Let me remind you what a radicand is. So, the value under the radical is called the radicand. And the little number inside is called the index. And we talked before when we did rational exponents that if there is no index, it's an invisible 2, right? Yeah. Hope you guys remember that. All right. So we need to make a list of of all the square roots and all the perfect cube, on all the cube roots.
Ow. Are you okay?
Radicand is what the number underneath is called. Yeah. Yeah. That's what we're doing. Alright, so let's make a list of all the square roots. We got the square root of 0. That's 0. We got the square root of 1. 1. We got the square root of 4. Wow. We got the square root of 9. We got the square root of 16. Square root of 25. Square root of 36. Square root of 49. Square root of 64. Square root of 100. Oh, I skipped 81. 9 and the square root of 100 is 10. Okay. Does anybody know what the square root of 7 is? No, that's 7 times 7. Okay. But that's 7 divided by 2. Does anybody know what the square root of 15 is? The square root of 38. Okay. All of the numbers in between here are weird decimals that we call irrational numbers. So today our goal is to only work with these numbers as square root. Today our goal is to have no decimals in our work. Okay? We're almost there. Let's do the cube roots now. I'm definitely more nervous about the cube roots. Yeah, these are your notes, and these are the lists that you can have out if you use open notes or whatever. Alright, so the cube root of 0 is 0. I know it's a cube root because there's a little 3 in there now. Like outer end. Like like that? Like that. Yeah. Like that.
So you can see the whole line.
Got it. Do I mess up again?
Yeah, she said she needs to see the
Yeah,
word.
perfect.
Alright, we got the cube root of 0 is 0. Cube root of 1 is 1. What's that?
27.
27 is 1. Very good. But there's another one before 27. 8. How do we cube root? Well, he means in the. I don't know how to use a calculator again, which I like. It's second. I think you gotta hit to do the cube root of 8. This is what you would hit. I think you would hit 8 first, and then second. Yep. So backwards. And then y to the x. And then 3. And then x. Yeah. 2. Maybe I'll put all the numbers. So I got. Alright, here's your powers of 3. These things are called perfect cubes. These are the numbers that we want to include in our list of cube roots. Okay? Just try 7. Sometimes I mess 7 up. 7 to the 3rd. Got it. 8 to the 3rd. Got it. 9 to the 3rd. Got it. Yeah, those are good. So I know you're familiar with the first list of squares, but being familiar with the cubes just takes a little bit longer. So we're gonna make a list of the cubes. This button will do like 3 to the 3rd.
Look it up.
Perfect cubes. So then we would do the cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root. You made this list?
No, I wrong. The 1, 2, 3, 4 in the cube. Wait, so is that just it? This list? The cube root or those all the
Yeah, weird how they're connected, right? These are numbers to the 3rd power. So rooting is the opposite of a power. So 5 to the 3rd is 125. So the cube root of 125 is 5. They're like opposites of each other, really. So after 125, that would be 216. So we did a whole chapter on exponents where we use exponents. Now our chapter is on radicals, so we're listing the roots. But they're the same thing, just opposite operation. And I don't know, like if you have these memorized, the math is easier. You know, so making a list yourself and writing them down, like I know you can look at me do it, you can take a picture of it, and that's better than nothing for sure. But you writing it down is what's gonna help you like remember it. So it used to be like flashcards and memorization, but now it's more emphasized. Can you use a list more than can you just memorize a list?
So it's like, example, 4 times 2 from the square root. 4 times 2 is 8. So then like 8 times 2 is 16. So I just go on and on. So 16 square root, but cube rooted by 4 would be 16.
Yeah.
What?
She saw the relationship of this to this. Like 9 times 9. 9 times 3 is 27. 16 times 4 is 25. Alright, so here's what we have to do today. We have to simplify radicals. So here's some helpful tips. Step 1. Numbers can be rewritten using roots. And so our whole goal today is to rewrite without decimals. Simplify with no decimals. So step 1, you identify if the radical is a square root or a cube root. What would you call this one, Jagar? Square root or cube root? See the little 3? We call that a cube root. No little 3 is called a square root. Little 3 is called a cube root. So step 1 is just to figure out, well, wait a minute, which list am I looking at? Am I looking at the square root list or am I looking at the cube root list? This problem in our example is a cube root. So we use the cube root list. Step 2 is to use the calculator to determine if the radicand has any factors that can simplify. Oh yeah, here's where you run them. Verse cube root. Which one is it? They're both in this section, square roots and cube roots. All right, so since 250 is a cube root, I'm gonna look at my list of cube roots. Is 250 in the list? I look and I see 216 and I see 343 and 250 isn't here. So I'm going to consult the list. Can 250 divide by anything in the list? Does 250 have any factors under this radical bar? 250 can be divided by 125. 250 and 125 are related, and 125 actually cube roots. So for 250, I'm going to rewrite it as the cube root of 125 times the cube root of 2. Does anybody know where I got my 2 from? 2 times 125 is 250. So you're allowed to separate radicals this way into a product. All right, so now we do have a number in the list. This number is listed. The cube root of 125 is 5. So I can make this a 5. The cube root of 2 can't go any further. So I'm going to box this up. This is considered the simplified version of this.
Could you how do you get 250?
You're thinking of multiplication and division. So, well, 250 is a problem. Like you're going to be given a number like this. Given 250, yeah, as an example, will it divide by any number in the list? So you can use your calculator or your knowledge. You guys came up with it without a calculator. Determine if 250 has any factors. It does. The factor is 125, so you rewrite it 125 times 2, and you actually cube root the 125. And your answer is 5 cube root 2. And then it's done. And this is simplifying radicals. Yeah. Yeah, so now you can see why this list is really helpful. Having it on paper is something to refer to. But yeah. If I gave you an index card, would you prefer it on an index card? Might be lost. I'll pass out an index card in a minute if you want to put one on an index card. You know, what if you flipped it like that? I think you could if you wanted to. All right, last one you'll have to do is. Okay, go back. It says use a calculator to determine if it has any factors that can simplify. So people recognize without a calculator that 250 divides by 125. So we didn't use one, but you can. I would get a calculator and I would just start like trying to divide by numbers in the list. Okay, we're actually gonna do. We can before I give you a more difficult one. No, I have to do the next example. No. Like if it's cube root to cube root, you can't switch it. I mean, there are strategies for switching, but you're not supposed to do that here. You're supposed to do that. All right, the last thing you'll need to do today is to separate fractions. FYI, fractions can be separated. So this is 15 over 64. You can just do it the square root of 15 over the square root of 64. You don't have to look at all that at once. The top and bottom can be separated. So then I would do the steps. Are we looking at square roots or are we looking at cube roots? There's an invisible 2 here, so I know this is a square root. Is 15 in the square root list? No, 16 is. Is 64 in the square root list? Yes. So I will leave the 15 up top and the bottom, the square root of 4 is 8. And so this is the answer. And that's what we're doing today. So I got 4 problems to do with you, and then you'll be in big ideas math. So go to page 795 and try 1 through 4. Travis, I told you to stay off that right now. What are you doing on there? What are you doing on this board today? Yeah, just jumping ahead. Put it on there just a second. You don't still have to log on to it. $7.95. We're gonna do 1 through 4. 4 more examples. $7.95. We're just gonna do 1 through 4 together, and then you'll be done. I'll be done. You guys can go on your own day. No decimals. No decimals allowed. No, if you got a decimal, you're not doing it right. Okay, it says simplify. Let me add exactly what you're saying. Simplest radical form. No decimals. Okay, so when I look at 24, I put it in my calculator, it's like 4.9 probably, right? Is that what you had? And that's because the square root of 25 is 5. Square root of 24 is not in the list. Does 24 divide by anything in the list? Okay. This is the square root list. Yes, 24 divides by 4. So I will rewrite 24 as the square root of 4 times the square root of 6. 24 is the same as 4 times 6. This can be really challenging if you just don't recall multiplication facts that well. And that's okay if that's you. It's just, you're going to have to rely on a calculator. You're going to have to like utilize some steps, the list. Okay, 24 divided by 4. Okay. Now what's the square root of 4? So I'm going to actually square root it, which means the radical is gone. The square root of 4 is 2. The square root of 6 is stuck because it's a decimal. So this is our final answer, 2 square root 6.
So, can you do that again?
Yeah. You have your list of square roots? Did you write it down? No? I can write it. Yeah, I'm going to do. Okay. Yes, but are 2 or 12 in the list of square roots? Yeah, so since 2 and 12 don't square root, that's not helpful. Yes. What were you doing when we were writing that list down? I'll show you this list real quick. So this is the list of numbers that will square root, and 24 does not show up there. So it goes to 25. So in my calculator, I will try to divide 24 by one of these numbers. Does 24 divide by 4, 9, and 16? Divides by 4. So I take 4 because it's in the list. So that's your strategy. You just look at the numbers in the list and see if it can be rewritten using one of them.
You use 6.
Well, because 24 divided by 4 is 6, I can't like change 4 times 6 is still 24. Like I can't just drop the 24 altogether, but I can rewrite it. So I've rewritten it as 4 times 6. So I can make it a bit smaller. It's a smaller number now.
What if it doesn't have like a number to it?
2 is the square root of 4. I square rooted 4 and made it 2. What if it doesn't have, what's your question? You hand up.
When you do the cause 54 is not rolling, so when I did it I got 216. So what do I do from there?
Let me do 2 real quick, and then we'll get to that. Sarah, what was your question? Was it on 2 or 3?
Oh, okay. The number, like a number to multiply it.
Just
Like
leave it
17.
You just leave it there. You just leave it there. Alright, so the strategy for fractions is to separate the top and bottom, and you do whatever you can. 17 is not on the list, but 100 is. I can square root 100. So this would be this. Oh, the negative sign's on the outside, not on the inside. This is the square root of 17 over 10. Now I have a 10 down there. It's a little smaller. It's a little more simple. Okay. Questions on 2? Yes. Because you don't want to separate it into like 16 plus 1. It would have to be multiplication. Only using multiplication. It's just out there the whole time. Just put it to the top. Alright. Number 3, step 1 is to identify, is it a square root or a cube root? This has the little 3, so we're going to use the cube root list. So I need to think about numbers that will cube root. I really don't know much about 24, but my list of numbers that cube root is 1, 8, 27, 64. So I really only have 3 that are less. I'm going to try these 3. Does 54 divide by 8? Use my calculator. No, it gives me a decimal. Does 54 divide by 27?
Yes.
54 divided by 27. It does. 54 is 27 times 2. So I'm going to use 27. I'm going to rewrite it as the cube root of 27 times the cube root of 2. That's the same as 54. I haven't changed 54. I've just separated it. And now the cube root of 27 is 3. So I can actually rewrite the cube root of 27 as 3. You get that part? That's from the list. So then this would be 3 times the cube root of 2. Brody, did you do number 4 yet? No. Did you do number 3? Left it behind. That's it, not me too. Alright, fractions, we separate. This is the cube root of 27 over the cube root of 8. Is 27 in the list of cube roots? Yep. It's 3. Is 8 in the list of cube roots? Yes. It's 2. 3 over 2. Or 1.5 is fine, but 3 over 2 is a little better. So that's the gym. Your assignment's on big ideas math. You have 10 minutes to work that out. It's more stuff about the negative. Negative first. If you want to keep your square roots on one side and cube roots on one side, and you have a pocket in your folder that you can pull this out and help you with using it next card. Negative different from the subtraction side? Oh, I got it. You gotta use this one.